Software Engineering Radio, episode 32, Pt.2a. Hello everybody to another episode of Software Engineering Radio. This is the second part of our series of episodes on service-oriented architecture. It is about using SOA together with model-driven development as well as several other issues on SOA. We also talk a little bit about some of the technologies that are involved with SOA. Now, this should have been originally one episode. However, after recording it, we noticed that it had taken us 90 minutes. So we decided to separate the episode into two episodes, and that's why we called it SOA.2a, and the next one will be SOA.2b. We didn't call it 2 and 3 because they're really basically the same session, just separated into two episodes. So this one is SOA.2a, and next week, or in 10 days actually, you'll hear SOA.2b. It's Eberhard and myself, Markus, who will be doing this episode. Have fun.
So, why are we talking about this topic? What is the kind of reason that you came up with it?
Well, I mean, everybody's talking about SOA, right? So I decided I had to talk about SOA too. And since I really always talk about model-driven development, I had to find a way how to talk about SOA and still talk about model-driven development. Okay, and now seriously. Anyway, so I got a little bit frustrated about some of the SOA talk and presentations and articles and stuff because everybody talks about specific technologies. I mean, people did understand in the meantime that SOA is not web services, but still SOA is considered a topic that can be solved with certain technologies, and I think that's really wrong. I think two things. First of all, SOA has a relationship to business processes, business cases, and these kinds of things. Some of that stuff you discussed in the SOA episode 1, the one where you explained kind of the basics of SOA. And on the more technical side, I think that SOA is really an architectural paradigm, an architectural style or whatever. And so I like to look at this topic from an architectural perspective. And if I talk about architecture, I really like to talk about models because models are a way of capturing architectural concepts formally and really fixing their meaning. So the idea of SOA becomes more touchable or more concrete. So that's kind of the motivation.
Okay, but I mean, on the other hand, it's one of the problems with SOA is probably that everybody says it's like the stuff that we always used to do, like component-driven development or integration and so on. So isn't that something that a danger that your approach also has?
Well, I mean, the good thing about SOA is that everybody can decide for themselves what it really means to them. And because it's not really very concisely defined. So some people think that SOA is basically component-based development as we've done it or as we should have done it for years. So you define component building blocks, they have responsibilities, they have interfaces, in this case called services. And they also use services that are defined elsewhere. Other people say that SOA is basically enterprise application integration, EAI, something that's been around for a long time. So you basically have asynchronous, loosely coupled message-based communications. Data structures have to be routed, filtered, mapped, translated between applications. And finally, some people say, and that's kind of what you said in the last episode, among other things, is that the most important part of SOA or aspect is the business process modeling aspect, where SOA is business driven. Every service has to have a meaning to business, and the factoring of the processes into a separate artifact or aspect is kind of central. Now I think that probably all of these views are correct or a part of what SOA really is. And at least all of these are problems in complex enterprise systems.
And that's actually something that I agree to. And there was also a comment on the last episode that basically stated that it was somehow focused on the externalization of business processes, and I'm not really sure whether that is the case. So basically I agree that from the technical side it's somehow somewhere in between those things.
Yep.
However, it's the business driven approach that is probably new to SOA.
It's business that drives all that stuff.
Yeah.
So that's the raison d'être or something like that. Just try some French. So and that's why I also think that the three views of what SOA means, which I just described, are actually fit together quite nicely. Because as the foundation of an SOA, you typically have a really well-defined component-based architecture. At the end of this episode, we'll talk about SCA, the new standard service component architecture, and they do exactly that. On top of that, you can then basically orchestrate business processes, and then using legacy adapter components or mapper or filter components, you can actually do the EAI stuff. So I don't think that the three views are kind of contradictory. They fit together nicely. It's just that everybody has their own, things. Some of one particular one of these three alternatives is most important
because it's a product vendor in that very space.
For example.
Mm-hmm.
So, and then there are two other things that are important for SOA, and they have also been around for quite a long time, and that is the separation between technical and business concerns, right? The idea that service interfaces only expose business operations, or that the data that goes, between services is business data, whatever that means. So the idea is to factor out technical concerns like security, persistence, or failover. Now, application servers have done that all the time, so that's nothing really new, but it's still important. And also manageability. You want to be able to monitor your services. You want to know which of the components have which level of load, to be able to manage things and also consider or take care about service levels, so you can actually guarantee some kind of performance. So maybe to summarize, I think if you talk about SOA, you have to talk about component-based architecture as a foundation for the SOA on top of it.
Yeah, and actually it's not surprising that those topics appear over and over again, because, for example, the separation of concerns is originally brought into play by Dijkstra. So it's quite an old thing. So therefore, it's probably the ghost that is going to hunt us for quite a while.
So maybe let's talk about a couple of additional requirements for SOAs or for complex and big systems in general. One is, I think you need to keep things technology independent. You must be able to migrate the infrastructure to tomorrow's new hype technology. So you have to make sure that the implementation of your business services and also, the description of workflows and processes and all that stuff is really technology independent. The other challenge that I really think is crucial is that things remain testable. If whenever you want to test a service, its functionality, like add two numbers in the most trivial case, you don't want to do a remote call using all kinds of enterprise service bus things. So you really need to be sure that you can factor out the infrastructure and keep the application logic testable.
Actually, you cannot stress the technology independence enough, because if you want to build enterprise applications, you're facing applications that run for decades, and you can surely not do every technology shift in those decades by migrating some code or doing things like that. You have to be somehow stable. And if you look at Java, for example, there are just so many new technologies that it's really crucial to be technology independent and to have an easy way to update your environment while not changing the business logic.
Yeah, and you can even take this one step further. I would say that probably the biggest problem today when migrating legacy systems is that legacy systems are typically built in a way where the different aspects or concerns of the application are not separated nicely, right? So if you take a piece of COBOL code or whatever, Java code for that matter, that mixes technical concerns that somehow, where the business process is hidden somewhere in the implementation of whatever artifact, then it's really impossible to extract the aspects and reuse them. So when talking about enterprise systems, and SOA in particular, it's important that the various aspects of the systems, service descriptions, communication protocols, processes, whatever, that they are described in a clear and in a clean manner that is not polluted by other aspects, and that's where models come in. But before we look at models, I really want to stress two other things. I've been on several SOA projects, a big one that I probably shouldn't mention the organization in particular, and so there are other requirements that I think are really crucial for SOA. One is that usually an SOA is something where the whole enterprise is involved. So you have many parties that want to be or have to be involved with this thing, and they have to be able to communicate effectively. So you need a well-defined set of terms and concepts that you want to talk about when designing your SOA. And also you need to stay agile with respect to changes. I've seen systems where when you added a new attribute to some data structure, it took a week until this change propagated through all the generated and configured and deployed other artifacts. So that's nobody's going to change anything in such an environment. And finally, you have to consider organizational aspects. Like, for example, if the SOA initiative is driven by some central IT department who wants to standardize their middleware, then the application development departments probably don't care about that. If for them introduction of SOA makes things more complicated, they will sabotage it. They will not collaborate. So you have to make sure that there is something for everybody when you introduce an SOA.
Yeah, which basically means that the real problem of introducing an SOA is probably on the level of the organization and the management and the business backing and things like that, which is something that is probably important for every kind of IT systems. Yes. But because SOA is typically such a large scale and interferes with so many systems and so on, it's especially important in that area.
Yeah, and also even if the business and your boss and the CEO and everybody really wants to do it, there are still a lot of technical challenges. So yes, I agree that you need to have the business things right, and everybody needs to support it. But still, if you have all that, there is still a lot of technical things to discuss. So it's still worth talking about the technical aspects of an SOA, even if you say that the business is kind of the most important driver.
Yeah, absolutely. I mean, my general approach is nowadays to say that technology cannot save a project. However, it can make it fail.
Yes.
And that's why it's important.
Yeah. Okay, then let's take a closer look at the role of models here, right? So I think abstraction is key when you define an SOA. And so it's really essential that you define metamodels and domain-specific languages then that actually describe the architectural concepts. You could, if you're an MDA person, you would probably call this an architecture PIM, right? It's a platform-independent model that doesn't describe any business concepts, but rather one that describes the building blocks of your SOA, such as services, components, quality of service constraints, deployment information, and so on. And again, this model has to be independent of the concrete deployment platform. You want to map this at a later stage to web services, JBI, SCA, whatever, Corba for the traditional folks. And of course, then if you map these conceptual things, once they're nicely defined and once you define the programming model, once you want to map these to implementation technologies, then it's obviously a good idea to automate this mapping. And that's where the model-driven development and code generation aspect comes in.
However, one thing that I'm wondering is especially with Pojo-based programming models, the code itself is already independent of the concrete deployment platform.
Yes.
So why is there still use for doing it with models instead of Pojos?
Well, first of all, I agree that Pojos with a couple of annotations can be a good starting point. And they are usually, if done right, independent of the deployment technology and of the middleware. However, in the end, what these Pojos do, if you define classes using Pojos that implement services, then you can only describe one of several viewpoints that you need to describe in order to describe a SOA-based system. So even if you use Pojos to describe or to implement services and basically to implement components, there are still many other things you'd have to describe for an SOA that cannot be, that cannot be kind of welded into classes and then annotated with annotations or something. So there's other stuff, and I'll go into that in a moment. If we want to be able to draw a model of the architecture, then of course, we need a metamodel that defines the words, the language elements that we can use in order to describe our architecture. And these language elements, the grammar for the language with which we describe the architecture, that's the metamodel. So to come back...
Sounds easy.
It sounds easy. It
sounds
is easy. Yeah.
Okay,
it
great.
Is. Okay. So I mentioned before that there are various layers that we probably want to describe. The lowest layer being component services deployment, the next layer business processes, and then some other layer with external services and maybe a legacy adapters or something. And in my view, to be able to describe the lowest layer, this component service layer of an SOA, you need at least 3 viewpoints. Viewpoints are models that describe a certain aspect or a certain view of the architecture. One is the type model that describes services, their interfaces, data structures, components, and which services these components provide. And at least as importantly and often neglected, the services which these components use. If you don't have that in your model, you only know who provides what, but you don't know who uses what, so you can't have any real dependency tracking. So, and that is the kind of model that you can describe with classes and annotations, Pojos. The next kind of model is the composition model, and that describes logical instances of those components and how they're wired. That means if I have a component address manager that provides some address query service, and I have another component, a customer manager, which requires a reference to an address query service. Then on the instance level, where I have an instance of the address manager and an instance of the customer manager, I need to connect those two, right? I have to connect the required reference from the customer manager to the address manager. This is the instance and composition model. And note that this is still independent of any specific deployment and technology. It doesn't say on which of your 5,000 servers a particular instance runs, and how big the pool size is and what middleware you use and which implementation technology. It's just a logical composition. And then the final model, the third viewpoint, is then actually the deployment model that maps your instances to technology and also to machines or processes or or application servers. You agree to that point?
Yeah, I mean, basically what you're saying is that it's still a component-driven approach.
Yes.
We need to define which components there are and how they're implemented.
Yes.
We need to have a model that describes how those components interact and where they should be deployed.
How the instances interact. That's really important. If you have, for example, in my project I was recently, they had, for example, the component, it was actually really called customer manager, and they had one in Germany, they had one in Austria, and they had one in Czech Republic, I guess. And so it was the same component, but it was instantiated 3 times in different, in this case, countries. So you really had to distinguish these different component instances when wiring them, because if the German call center would happen to access the Czech customer database, that's not very useful.
Yeah, it might be fun, but not really useful.
Yeah. So the meta models for these models are I mean, it's really hard to describe. Meta models are graphs, so it's a bit tough to describe them in an audio only form. But the type meta model contains, as I said, components, ports, services, maybe a definition of how the service expects interactions, like, send me this message, and then within 5 seconds I'll reply either with this reply message or with that error message, right? And then of course you have to define the data structures that the services use. You will often, in this case, you would use XML schema. Yes, it's not technology independent, but it's so ubiquitous that it's acceptable to bind yourself to the technology there.
So I mean, basically, this is like WSDL, or IDL, and things like that. It's just on the same conceptual level.
Yes, absolutely. Yes. I mean, the problem with WSDL in its 1.x incarnation is that, first of all, it doesn't really define the notion of a component, and also it doesn't really define any non-trivial protocols. Like, for example, you could associate a protocol state machine with a service definition. That's how the embedded folks do it. Why not do it the same way? In WSDL 2.x, things are getting better. There is the notion of a component, and you can define which services a component provides and also which services a component uses. So WSDL 2.x is really much closer to what I'd like to see. WSDL 1.x only provides, only describes a service from the provider's point of view, and that's absolutely not sufficient to describe a system.
Okay. Yeah. My point was to provide an analogy
something to relate to,
grasp the concept.
Yeah, but I mean, still worthwhile to talk about the differences.
Yeah.
So,
absolutely.
And then, as we said before, this composition metamodel contains component instances, which are obviously instances of component types defined in the previous metamodel, and then the wires between the components. So that's between the component instances. And then finally, the deployment model metamodel contains concepts like system, node, container. And of course, if you do it right, then you can, if you say, you have this node like server XYZ, and on this runs a J2E container, and you deploy an instance to this container, then your generator can derive from that which kind of glue code it has to generate in order to have your POJO implementation of the service run on the particular infrastructure. So that's actually really neat. You can derive a lot of interesting information from that, from these 3 viewpoints. And of course, you can vary all of these 3 viewpoints separately. That's actually why we have 3 different models, one for each viewpoint. You can take the same logical composition model and deploy it on different infrastructures. One infrastructure is typically everything in one process running on top of Spring, for example, for unit testing. And another infrastructure could be the highly distributed, scalable J2E whatever system, and I'm not implying that Spring is not scalable, which is your production environment. You don't have to change your composition model or your component implementation. It's just deployed on a different infrastructure, different glue code is generated, and that's it.
In the case of Spring, there wouldn't even be glue code generated, but it would rather be a different Spring Spring configuration.
Yeah.
But it's still the same thing. So you would basically generate something that says, please talk to this server over HTTP, while for the unit test you would probably have everything running local on one node. Another thing that just crossed my mind, this is very much like the new Visual Studio stuff.
Yeah.
So do you want to talk about that, or?
I mean, first of all, as I said, I haven't invented all the stuff I'm talking about. So there are several other initiatives that think in that direction. SCA is one thing, and also then this. In Visual Studio, whatever, I think 2005, Microsoft has built a set of modeling tools based on the Microsoft DSL tools, software factories and stuff, where I think they're called Enterprise Designer or something, where you can actually really graphically deploy and your services onto your hardware. So yes, it's the same idea.
Okay. But not using UML, but...
Yeah, I'm not talking about using UML either.
Okay.
You can use UML if you want to, but you have to, you have to come up with some kind of notation. It can be a textual notation. You can build your own textual DSL to describe these things. It's quite nice because that makes diffs and merges based on CVS much easier than if you have graphical models. But that's a different topic. So one last comment on these things. I talked about defining the connections between component instances in this composition model. And that sounds as if you'd have to define all those connections statically when you model your system. And then there would be no dynamics in the system at all. Yes, that's one way of building an SOA. However, there is no problem in adding dynamics by saying, okay, instead of wiring two component instances directly, the alternative would be that you just specify in your model which information should be used at runtime to find the target of your wire or of your connector, based on some registry or naming service or UDDI or whatever. And so then you can have formally you still have a static, you still draw a line between two component instances, but the line actually doesn't really point to another instance. It basically points into nowhere, and the connector has a number of criteria by which at runtime it will find a suitable component instance. That's also a very old concept. In Corba it was called Trader.
In Spring, it's called auto-wiring.
Right. Not really, because I thought auto-wiring basically gets you some arbitrary instance based on type equality. And that's not what I'm talking about. I really think you should still describe additional properties, like you need a component with this service level, or a component instance with this service level, located in that country or whatever.
Can you give an example where this is really useful?
The scenario is as follows. If you have, again, this customer manager thing, we said we have two customer managers, or three, one for Germany, one for Austria, one for Czech Republic. Now, if you are the German call center component thing, then you have to talk to a component instance that provides the customer manager interface and that manages the German customers. Okay, so one of the criteria for the lookup would be I need one that manages German customers. So what you could do is in this query to your trader service, you could say, give me a component instance which provides the customer manager interface, which manages German customers. So there would be a property, country equals Germany. And there might still be 5 or 6 instances of that component running in different cities in Germany or redundantly in some computing center. So there is still some dynamics in there, but it's still it's a lookup based on properties, and that's what traders do.
So the real advantage is if I add another system for, say, France. And
no, that won't change anything, because I won't find that, because I query with country equals Germany. But if I add another machine in my computing center, or another computing center in another town, I would then, load balancing, failover wise, I would then maybe find the other component instance that satisfies my query.
But that's just another layer for doing load balancing, which you can do on a lot of different layers.
Oh yes.
So I mean, I got the impression that the real advantage is that my system can easily integrate additional countries, for example.
Yeah, that's another thing, but that would also require that the configuration data in that connector can actually be changed at runtime. So the only point I want to make is that although it sounds like a completely static configuration, it's not the case. It's very easy to adapt this to dynamic scenarios if you need to. That's my whole point.
So let's take a concrete example like the customer service you mentioned, and see how this is actually taken into real life and real code.
Right.
So what do I do first to get this thing running?
So first what you have to do is you have to define the types you work with. These are the service interfaces, your data structures, and the components which which provide or require interfaces.
So taking the example of a customer service that we've been talking already about, how do I actually get this to do something useful, to get it running on some machines?
Right, so I start by defining an interface, for example, iCustomer query that contains an operation get customer data, and you pass in some query parameters, like, for example, the name of the customer or whatever. And then you define a component, it could be called Customer Manager, which provides this interface we just defined, and maybe that requires an interface database manager in order to access the database. As I said, it's really important that you don't just define what a component provides, but also what it requires, to close your dependency graph. So you have to model that in some way, and how you model that depends on what you decided you want to model with. This can be UML, it can be a textual modeling language. I mean, that's now a really technical tooling problem that we probably shouldn't cover in this episode. That's just MDSD stuff.
Yeah, but that's where the meta model comes in. So the meta model decides whether you do it with boxes and lines, or whether you write it down in some textual way, and what you write down.
Not at all.
Like
not at all. The meta model defines. Good that you asked that. The meta model defines what concepts are available. Interface, component, the fact that a component can provide an interface, and so on. The concrete syntax for your domain-specific language, what defines the visual appearance, whether it's going to be text or graphics. So that's really kind of orthogonal. You can have several concrete syntaxes for the same meta model.
So is there kind of like the general universal meta model for this kind of applications that we are talking about?
I mean, there are a couple of best practices. I've captured some of them in some of my papers and patterns, and then of course there are some meta models defined as part of, for example, the SCA standard. Also WSDL 2.0 has a reasonable meta model. So there are various places where you can go and get inspiration from. However, and really great you ask, the point is, I really wouldn't go and, get something from somewhere and buy a tool that does all that for you. This is where you define your architecture. This is the master plan for your systems. Do this yourself. Inspire yourself, get ideas from others. Don't reinvent the wheel, but don't just, download something and, use a tool. This is the master description for your world, for your IT world. You really should do that yourself. It's going to bite you if you just follow some vendor and do something. Yes, if you're going to use SCA, then take a look at their meta model and don't invent things that are completely different, but keep that to yourself. Okay.
So basically you're saying that you should still do it yourself, because the standardized
there is no official standard.
Yeah, because it basically defines your architecture, and because
yes.
the architecture is different for each and every application, it's more useful to do it yourself than to buy it off the shelf.
Yeah, I mean, there is still a lot of stuff to buy off the shelf. All the middleware, the enterprise service buses, compilers, IDEs, monitoring tools. There is still a lot of stuff you can buy, but this is the master from which all of the other systems are populated, or otherwise, you generate configuration files and all that. And since this is really the master, you really must make sure that it's under your control. Okay, but let's get back to how we implement that stuff. Now, once you model the structure of your system, components, interfaces, services, you can now generate, for example, an implementation skeleton. Could be a Java class, which contains a couple of infrastructure things, like, for example, the provisioning of the interface and other things. And you extend from that class and you implement the business methods manually, for example. So at this point, we don't consider implementing the service as something we want to do in a model-driven way. The model-driven stuff is just the technical infrastructure.
What do I do when I want to integrate some legacy system?
Can you defer this question, or can you ask it again later? I mean, I kind of would like to go through this thing once, and then we can discuss this later. I think we have it on our plan anyway. Okay. So and now once you defined the implementation for your component, or actually you didn't define it, you programmed it, right? Following some restrictions provided by the code generator and constraints and stuff. Then you're able to define a composition model as well as a deployment model, and you can actually already run the system, assuming you have the generator that generates all the glue code that maps the implementation or the POJOs onto your whatever infrastructure, right? So before we go on with the next kind of topics, I really would like to discuss an additional aspect, which is asynchronous communication. we kind of assumed implicitly while in the previous discussion that we have this kind of remote procedure call thing, that a service invokes procedures defined by another service, or a component actually invokes operations defined by another component. That is just one implementation alternative. So there are actually 3 ways you can do this. One is you can define operations, as we just said, and basically implement them, invoke them synchronously, just remote procedure call. The second way you can do it is you can define how, if component A requires an interface provided by some other component, then you can define as part of this requirement whether the other interface should be talked to synchronously or asynchronously. And if you, for example, say that your customer manager wants to talk to the address manager asynchronously, then the interface that you as the customer manager see, the Java interface that's generated particularly for you, has an asynchronous notion. So you would have, like, instead of calling an operation, you'd get the return value, you'd get alternatively you'd get a future, just future pattern, which is basically an object on which you can poll the return value as you want, when and if you want to poll it. So depending on how you want to communicate with your peer component, you just mark that up in your model, and the generator generates the necessary API and all the middleware configuration so that you can actually communicate asynchronously. And the third implementation alternative is that you don't really define services as containing operations, but rather the service interfaces just contain messages. So you would basically define a message-oriented interface. So we can discuss which is better, and which is more loosely coupled and which is more service-oriented. The community kind of gravitates towards the message-oriented view, but that doesn't change the picture. It's just that the interface is not defined as a set of operations you call, but rather as a set of messages that your component or the provider of the interfaces can understand. And usually you also define a protocol that says which messages go in and which are the replies, and how these replies are associated and related to the requests.
Yeah, and I mean, message-oriented middleware is really strong.
Yes.
And is probably driving most of the larger enterprise systems. So it's important to bear in mind that not everything is done by remote procedure calls.
Right, it's just that the boundaries between those different approaches are really blurred, because, for example, if you have this message-oriented interface, you can still generate an API for your clients that basically looks like void methods, and you get callbacks for the reply message. And that is, from an API point of view, it's indistinguishable from asynchronously called operations. Okay? So it's really important to distinguish the API and the programming model from the underlying metaphor and also the middleware. Okay, so where does this get us? It gets us to the point where we can implement components, service providers and service users, without a technology dependency, without deployment information, without knowing with whom, with which other instances they really interact, and without knowing on which platform they will run.
But it's just a description, right? It's not the actual code that is executed.
It's also the actual code. We have already implemented the POJOs by deriving or extending from the generated skeleton class that we generated from the type viewpoint model.
But the model itself just generates the skeleton, not the implementation itself. Absolutely.
We will later in the discussion we'll consider also generating some of the implement or particular kinds of implementations. Now that we have all that in place, so that's basically the fundamentals, I think we should talk about a couple of issues in the context of SOAs, right? For example, data ownership. If I define a service and also define its interface and components and all that stuff, and if I want to interact with somebody else, then we have to agree on data structures. If I send you a customer with a certain data structure, and you don't know this data structure, you can't work with this customer data, right? So historically, people have talked, about the business object model. So there was this big object model that contains all the data structures you need in your business. And that's, of course, a really big problem, because this was kind of the bottleneck with regards to changing stuff. In case you ever agreed on something, you weren't able to change it ever again, because if everybody uses it and you change it again, everybody else, has a problem. So this is something that historically didn't really work. The other approach in SOAs that's sometimes taken is that you say that data structures are strictly local to a service. So if I define a customer data structure, then this data structure can only be used by my service clients, and they can't publish it again. So that means, of course, that if you have data structures that you use all throughout your enterprise, then you have several formal definitions of the same logical concept. That's also a problem.
Are you sure about that? Because my impression is that, sticking to the customer example, everybody in the company has a different view on the customer. So one is interested in his address because he want to ship something to him, and somebody else is interested in his telephone number or email because they want to do some marketing stuff with him. And therefore the question is whether this central business object model really makes sense, right?
I think these are two aspects. There are certainly some data structures that everybody agrees upon, or conceptually agrees upon. On the other hand, you're absolutely right that usually data is viewed with different properties from in different departments. I think we'll cover this aspect later, so that's just a different thing.
Oh, and the other thing that I'm wondering about is, if you do have this centralized object model, it's still probably not worth it because it doesn't take into account the requirements of the specific applications, which therefore might even... So, I mean, a client is probably interested in displaying the data in a certain way, while a backend system is probably interested in operating the data in a certain way that is different and has different requirements in terms of how the object model should ideally look in terms of making the development easy and also making the stuff performant.
What you talk about is a kind of controlled variability in data descriptions. If I want a customer, then I just need certain aspects or attributes, and you don't need these, right? So this is something different. The point I was going to make is that there is a middle ground between having the big business object model which doesn't work and the strictly local service strict locality of data to a service, and that is basically that you add another concept in your models, and that's you could call it like domain or a subsystem or whatever, which bundles a set of components, services, and their data types, and then you can associate components with this domain. Then there is a dependency, but you don't make the dependencies global. So you have a way of controlling kind of the spread of your data type. And again, this is something that you can easily do if you have models, because you just add this concept of a domain and it collects a number of components, and you can easily control all your data type problems.
So in that case, I need to have the data types in the component model as well. And basically, I need a model of the whole IT infrastructure of the company.
Yeah, you define things like departments or domains, which say, there is the domain customer-related stuff, which contains the following 7 components of these 4 departments, and they have agreed on a certain data structure. But anybody outside this domain cannot access this data structure. So the dependencies on this data structure are not going to, spread widely all through your enterprise.
Yeah, and the interesting part is that the model is global to the whole IT system of the company.
Yeah, that's again another thing, whether you want to have a global model which everybody changes, or whether there is a more distributed development style. That's something we'll talk about later, but that's a related but different aspect. Okay, let's talk about typing a little bit. If you consider Corba, then the data structures are defined, using Corba structs in your IDL files. And then you generate from that, these interpreters basically that parse the binary data and build the C or Java or C++ or whatever data structures. That is, of course, still something you can do in the context of SOA. No problem with that. It's probably more efficient than anything else. However, there is one problem, and that is versioning and compatibility. For example, in Corba, what usually happens if the two parties, client and server, don't have the exact same definition of a data structure, basically the parser fails, throws an exception, says, I don't understand this. And that's, of course, a problem if you have a big distributed enterprise and you want to keep things agile. And in that case, it is really useful to interpret the data structure. And the primary means of describing data structures that will be interpreted is XML. And that is why using XML as data structures is actually an advantage over binary implementations as typically done in Corba. It's not because it's human readable or all that crap. XML is not human readable once it gets sufficiently complicated schema wise. The point is that a parser that reads the XML can easily skip attributes or elements it doesn't know. It can also add default values. You can even, tweak your interpreter to, if you receive data that is an old version, then you can kind of magically update it. It's something which might be work to do. It might be tedious, but the parser won't just fail. So that's a bit more robust. So it is a good thing if you have data structures that are not strongly typed in the sense that your generated or compiled code depends on its particular structure, but rather it should be interpreted. However, there is one really important thing you have to keep in mind. I'm not suggesting that you shouldn't clearly define your data and then, you have this method, do it, you pass in a string, right? That's nonsense, because then you have no type information anywhere, not even in the models. So what I'm saying is you should clearly define your types, for example, using XML schema or UML or anything else. And the two endpoints of your communication should be able to determine which version of your data they're talking to or they're receiving. They should parse it, types in a type-safe manner. But all the intermediate structures, all the brokers, all the middleware, all the monitoring stuff, they should not depend on the specific data structure. They should only interpret it. And therefore, you can easily change a data structure without having to regenerate and redeploy and all that of the complete intermediate technical infrastructure. That's kind of important.
But you would still redeploy each and every client and server that that depends on the data structure.
That kind of depends. If I, as a service provider, add additional attributes, for example, to my customer, then I do this because I expect that my clients are interested in that additional data structure. Okay, so if they're interested in that new data attribute, they obviously have to change their implementation and they have to be redeployed. Okay, but if there are 3 other clients which are not interested in that particular attribute, they shouldn't have to care. So I only should have to redeploy those participants of the, members of the domain, to speak in the terms of the previous kind of discussion, that are really interested in this change, and the others shouldn't stumble about the changed data just because of technical reasons.
Okay, so what you're saying is not just the technical infrastructure, but also the clients should be stable towards changes in the data model.
Yeah, ideally, yes. I mean, again, we were getting into semantics here. If, for example, there is a new additional attribute for my customer, and I really want to make sure that all my clients take care of this attribute, for example, is allowed to get credit. This is a kind of semantic information that I want everybody to consider. Then I maybe don't want the clients to, just skip the attributes if they don't care. So maybe you have to introduce the concept of changes that are, that are optional for clients to understand, and changes that are required. And so, again, if you do it model-based, it's easy to do this because you can mark up all these things in your models, okay?
Yeah, the model that you described before only models dependencies on the level of data structures, while in the case that you're explaining now, you need to model dependencies on the attributes of the
Oh,
data
no,
structure.
not really, because what you do is you would just simply version things, right? And you would say this new version of the data structure is one that is compatible to the old one, so the old clients should continue working, and the other next version is one that is semantically incompatible, so the clients shouldn't just skip over. And then there would be some logic in the clients, which would be generic, that says if the client has been built with version X and now comes version X +1 and +1 is semantically compatible, then try to skip all the stuff I don't know. If it's incompatible, throw an exception, say, hey, you're outdated.
Yeah, but which could lead to the situation that you can hardly update your system.
Yes, but the point is that you would, of course, try to minimize use of those required changes. You know, you can now deliberately decide which you want to do. If you have the compiled interpreters like Corba, then things are just going to crash.
Yeah, and it's, I mean, in some cases it's really an advantage. There are some projects like that, for example, try to change the customer number from 6 digits to 8 or stuff like that. And those projects are probably the hardest to do in a company, because each and everyone relies on the fact that the customer number is six digits. It's almost like a small Y2K problem.
Yes, so. That's a good comparison. Okay, so here is where we break for today. SOA2b will be there in 10 days. See you there, and thanks for listening. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.